Okay, so this is the 2018 VCE Methods Exam 1, question 3. Two parts to this. They give us a function. You might just be able to read it there at the top of the screen. The function is 2 cos of x plus 1 between 0 and 2 pi inclusive. And the first thing is they want us to solve that function for a particular value. Now, part B of this question actually asks for a sketch. I'll get to that in a few minutes. But I always like to get a sense of, what's this function all about? So with a question like this, certainly if I was doing it in class or in a class, I would sketch the graph first, just to get a bit of a sense of, where I'm expecting particular solutions to be. So just to give you an example with this, obviously in an exam, I might not have time to do this. So you might want to do things, mix things up a little bit. But just to give you a quick idea, if I'm doing the function, for example, y equals cos of x, then we know that between, so here's, I've got pi, I've got 2 pi, I'm only doing the function over, one cycle. The cos function starts at 1, drops down to 0, down to -1, back up to 0, and finishes when x is 2 pi at 1 again. So that's my basic cos function. This one is a basic cos function that's had 2 transforming parts to it. Its amplitude has been doubled, so it's gone up to 2 and down to -2. So in this case, it's going to drop down from 2 to 0 to -2, back to 0, and then up to 2. So that's y equals 2 cos of x. And then that whole graph has been shifted vertically, 1 space up. So instead of going from 2 to -2, we're going to go from 3 to -1. So you can imagine a little I like to have a little dotted sort of reference around which the trig function is cycling, and that in this case it's going to be 1. It's normally my x-axis, but in this case the whole thing is shifted up. And so at my particular values, it's going to start at 3, it's going to drop down to 1 at pi on 2, it's then going to drop down to -1 at pi, back up to 1 at 3 pi on 2, and then finally finishing at 3. So my graph would look something like that. So that's the graph of y equals 2 cos of x plus 1. We want to actually solve that in part A. We want to solve that function for the function equal to 0. So we can see where it's equal to 0. It's here and it's here. Right? It's equal to 0 at those 2 points. So basically we're looking for those 2 points. Just as a sort of a guess off the top of my head, if that's going to 2 pi, it looks like we're sort of dividing that up into thirds perhaps. All right, I know what I'm heading for in this particular question, so maybe that's a bit of a trick. But at least you can get a sense, if you can do this quickly, of what sort of solution you're looking for. Okay, so let's actually do the solution. So our problem is solve this function. 2 cos of x plus 1 equals 0. So obviously what I want to do is rearrange this a little bit. I'm going to take 1 away. So I'm going to get 2 cos of x equals -1. I'm going to divide by 2. So I'm going to end up with an equation cos of x is equal to -1/2. And I want to solve that. What values of x make that true? So here's where I'm going to need to find a reference angle. So I'll look for something that allows me to do that. Hopefully you recognize, one of the the standard trig triangles, the 1 to root 3 triangle with pi on 3 and pi on 6. And hopefully you can see that if this problem, so if what I was trying to solve was cos of x equals a half, then, all right, there's a half. Remember, cos is the adjacent side, so that would be my adjacent side, my hypotenuse. So the angle, the base angle, the reference angle, I'll call it the reference angle, would be pi on 3. Okay? So that would be my solution if it was a half, or at least that would be one of my solutions, because remember we're talking about a circular function, and so we can have multiple solutions. But of course, we don't have that. We've got cos is equal to minus a half. So we need to tweak this reference angle or modify it in some way. I'm just going to remind you about, in the unit circle, about the ASTC across the quadrants. And because we've got cos of x is equal to minus a half, that's what we're trying to solve, we know that cos is a negative value in the second and third quadrants. So the solutions are going to occur in the second and third quadrants. So my solutions are going to be not pi on 3, but in the second quadrant, that would be pi minus pi on 3. And in the third quadrant, that would be pi plus pi on 3. So my solutions are going to be pi minus pi on 3 is 3 pi minus pi on 3, so 2 pi on 3. And this one's going to be 3 pi plus pi on 3, so that's going to be 4 pi on 3. So my solutions are x equals 2 pi on 3 and 4 pi on 3. And you can see if I can locate what was originally my sketch. No, I've lost it. But if you remember from my sketch, I did say I thought it looked like it was about thirds that we were dividing this up into, and that's a third of 2 pi, 2/3 of 2 pi. So that's typically what I was expecting. So that sounds good. So that was 3 part A. Now for 3 part B, I'm not going to do that on a separate sheet of paper. 3 part B was a sketch. Now, of course, I've already done this, so I really just need to identify, a couple of those key points. The question says, sketch the graph of the function f on the axes below, label the endpoints and local minimum point with their coordinates. Now, remember, this function we only want the function between 0 and 2 pi. So the endpoints are going to be when x is 0 and x is 2 pi. And the local minimum, because we're going to have a cos shape, it's going to have a local minimum at pi somewhere. So I can identify the key points that I've got. It was, if you remember, at 3, the basic, when x is 0 for cos x, it's at 1. But remember, we've got doubled the amplitude, and then we've added 1 to it. That's going to be 2 pi as well, so it's going to be there. So those are going to be my 2 endpoints. I know that it's going to, ordinarily, if it was just cos x, it would go through, when x was pi, it would be, the y value would be -1. Remember, I doubled the amplitude, the 2 in front of the cos x, and then we lifted the whole thing up. So actually, it takes it to there. And I've got solutions for when y is 0. That's what I was doing in part A. 2 pi on 3 and 4 pi on 3. So I've got those points. That's good enough to get a sketch to look something like that. The shape doesn't need to be perfect, and this clearly isn't going to be, but something like that. So sketch the graph. Now the only other thing is label the endpoints and local minimum point with their coordinates. So here's my local minimum. The coordinates for that are pi. and -1. My two endpoints, the first one over here, the coordinates are 0 and 3. And then on this one, my coordinates are 2 pi and also 3. And that's it for 3 marks. Pretty sweet.